Stephen Koonin, welcome to the Inquiring Mind podcast.
A pleasure to be talking with you.
Yeah, it's a pleasure to have you on the podcast. I say that to everyone because it really is a pleasure. It's always nice to discuss big ideas, and it's really important to discuss the ideas you outline in the book I have right here, Unsettled, what climate science tells us and what it doesn't and why it matters. Before we get into all that, I'm not going to ask for the elevator pitch, who you are, what you do. I found out that you grew up in Brooklyn, like
I did,
as did I. And I still live here. How did that experience, maybe let's start with this. How did your time in Brooklyn, maybe your upbringing, lead you to become a physicist and to what you do now?
From a very young age, I would say probably 3 or something, I was fascinated with how the world works. And fortunately, I had parents who were more than willing to feed that interest. My father would explain to me as a young child how the stars worked, etc. My mother encouraged me. I had a wonderful set of teachers in public schools who nurtured what I did. And it was very much it's funny to say, earthy experience growing up in Brooklyn. It was a middle-class neighborhood in the middle of the borough, pretty diverse, Jews, but also Catholics, Protestants, Asians were starting to be living there as well. And it was just a wonderful experience. I really value it as a place to be growing up.
Yeah. And how did you first become interested in science as a whole? I know you just said you were always curious, but was there a moment that that really struck you as this is the turning point?
No, I had diverse interests when I was a kid. Music was important to me as a youngster and still is an important part of my life. If I had my druthers, I'd be playing piano in a bar somewhere. But I was fascinated again with the way the world worked. I was good at math. And it was, I think from a very young age, there was just no question. That's what I was going to do. And I'm fortunate to have lived a life where I've had the privilege and the fun of doing it.
Right. And why physics in particular?
Yeah, physics is, other scientists hate when you say this, but there's some truth to it. Physics is the most fundamental science. It is the science of matter and energy and how they interact with one another. And the tools that you learn as a physicist and the attitude that you learn as a physicist, data, models, reductionism, sometimes integrated behavior of systems, they serve you well if you want to go off and poke your nose into other business. And I have many physicist friends who that's become their main occupation, is to bring physics to geology, biology, chemistry, neuroscience. And of course, I've dabbled a bit in that myself. It's just great fun.
Mm-hmm. I once heard a podcast with Walter Isaacson, who famous biographer, and he said that I hope I'm not making a mistake here, but he said that we teach science in this country in the reverse. So what we teach is biology, chemistry, physics, but it should be the other way around, where it's physics, chemistry, biology, or maybe chemistry, physics, biology, chemistry, whatever it is. Do you agree with that?
Yeah, I think there's a lot of truth to that. I can tell you, growing up and going through the New York City public schools, I was subjected to biology and earth science and chemistry before I finally got to physics in the 11th and 12th grade. I mean, I knew, of course, I had read enough to know I was going to do physics, but I absolutely hated those other subjects because you had to know too much. It was a lot about memory and knowing facts, whereas physics, if you just know a few principles and you're clever at how you apply them, you can get a long way into it. And now, of course, as an accomplished physicist, I find great joy in learning about earth science. The climate book is a lot about that, but also biology, neuroscience. These are wonderful subjects, particularly if you come at them with a physicist's set of skills and attitudes.
And what are some of those attitudes? Before you answer that question, in the book there was a funny moment in the introduction, I believe, where you said being a physicist or being a Caltech, which I want to discuss in a bit, is like the Big Bang Theory, but without all the funny parts. It's funny because I'm watching the Big Bang Theory now, but how does physics shape the way you think?
Um, like all scientists, first of all, it's a question of curiosity. Why is that? How does that work? But physics tends to want to try to explain things in terms of fundamental principles. So it's reductionist, but it's also very quantitative. There's a famous line by, I think, Rutherford, who was a famous physicist, who said, unless you can quantify it and put it in numbers, your knowledge is of the most meager kind. And so there is this urge to quantify and then apply mathematics, statistics, inference, models in order to explain what you see. And, I contrast that with some of my biology friends who are much more integrative in the way they think about things. They have wonderful memories and are able to connect disparate pieces of knowledge together, but some of them don't have that same let's measure, let's quantify, and let's see if we can explain.
Obviously, from your time in Brooklyn and New York, you then moved on to California. You attended Caltech, which is arguably probably the most prestigious universities, especially for aspiring scientists and definitely physicists in the world. You describe an experience you had with a person that I know a lot of people are inspired by, and that's Richard Feynman. Can you describe what Richard Feynman was actually like and what he taught you?
Yeah. So just a little bit of background. I finished up at age 16 in the New York City public schools. It was the late 60s, and it was time to go to California for a lot of people. Summer of love and all that stuff. But more importantly, Caltech had a reputation as being the most rigorous place to go do science. And so for that reason, I was determined I was going to go there, and I did. Dick was an important figure on campus then and persisted through his death in 1987, I think it was. He was wickedly smart. I probably have met one or two other people who are as smart as he in different ways. He had a way of looking at the world differently and gaining really interesting insights from that, but he also had the physicist's tools of quantitative model building and so on. But he was also a personality. He was a showman. You just have to look at the lectures to see that and there are films of the lectures, of course, to see that he loved performing. And also he had an intellectual rigor, which I think, as I write in the book, certainly rubbed off on me and everybody else who was at Caltech at the time. So a wonderful guy to interact with. I was fortunate, as I said, to wind up playing the bongo drums with him one evening when I was a freshman. What a treat, right? An inspiration. I mean, as I've gotten further along in my life, of course, I have other figures who've inspired me as well in different ways, but he was pretty singular as a physicist and as a personality.
Yeah, it's quite clear, again, from your introduction and from the rest of the book, how seminal your experience at Caltech and learning from a person like Richard Feynman was to your intellectual curiosity. You weren't bogged down by trying to prove a point. You were just trying to analyze data. Again, before we get into the crux of the book, which is obviously, some people quote it as, try to frame it as controversial. I don't see it as such. I see it as just an open discussion of ideas. How did you first become interested in climate science? And what inspired you to finally sit down and write this book?
Yeah. So I first got exposed a bit to climate science in the course of doing some consulting work for the government through a group called JASON, which I describe in the book. There's a bunch of 40 or 50 academic physicists who do various projects during the summer for various government agencies. And there was a stint in the early 90s where we did some climate-related studies. The application of high-performance computing to climate modeling, the application of small satellites, CubeSats these days they're called, to monitoring climate, things of that sort. And so I got some exposure to it. I became much more seriously, well, I should say I got interested enough in that time to start up my own little observational program together with collaborators from Caltech and then later on from the New Jersey Institute of Technology, where you can kind of watch the moon and learn about the reflectance of the Earth. And that's a nice little phenomenon to try to exploit. So we've been doing that for 30 years or so, almost 30 years. But I got seriously interested when I left Caltech in 2004 to become the chief scientist for BP, the oil company, British Petroleum. And I joined them with the expectation that I would help them figure out what beyond petroleum really meant. And of course, one of the prime drivers for moving beyond petroleum is concern about greenhouse gas emissions. So I learned some about that, about climate science in the course of that, but much more about energy technologies. And I think the real turning point for me from going from how can we save the planet to wait a second, let's really try to see how solid this science is, was in 2014 when I convened a workshop for the American Physical Society. We had 3 consensus scientists and 3 skeptical scientists, and we really stress tested the science. And I came away with 2 observations. One is that this science is not as solid as I'd been led to believe by the media and other scientists I've been talking to. And secondly, that I'd been misled, and the media played a big role in that, in portraying things as more certain and more dire than what the science really said. And so I moved along for subsequent 5 or 6 years, watching how the science was portrayed, reading the science myself, and eventually got to the point where I wasn't making any headway in trying to get a more honest discussion in either the media or from some of the science institutions. And so I just decided to write the book. And the book is, the way I like to think about it is, you know, you can start with the basic research, the research papers, the fundamental data. It gets into the assessment reports that are put together by the UN and the US government, the summaries of those assessment reports, which are written or have the heavy hand of the government in how they're written, and then to the media and the politicians. And I watched this growing disconnect between what the public was getting and what the politicians were saying and what the science really said, either in the literature or the assessment reports. And so I decided to just circumvent that whole chain of information and get right to the assessment reports and make them accessible in many ways to ordinary readers.
And obviously, one of the main themes is the fact that there is this major disconnect, and the major disconnect between the public and the science. What's a little frightening is I always expect the politicians to, you know, be politicians. That's the one constant in the world, right? And I'm going to say average human beings living life and paying taxes, paying bills, to just go along with what they hear. And it shouldn't, the burden shouldn't lie on them to go out of their way to get all of this information, because it's difficult to obtain all this information and to read scientific documents. The frightening part is the fact that the scientists themselves know that this is true, yet a lot of them are afraid to say anything.
Yeah, I would fault many of my colleagues for not speaking up. But also some of my former friends, perhaps, keep using the words existential threat and climate crisis, and there is no grounds for that in either the assessment reports or the underlying science. And I think they're derelict in their advisory duties by either not speaking up or by helping to perpetuate that kind of misinformation.
Mhm. And when you put together a proposal for your book, did you encounter a lot of difficulty in the publishing process?
Um, let's just say that there were a number of publishers who received the manuscript. Many of them said, "This is really interesting, but we can't touch this." And I was fortunate to find the publisher that I have, Ben Bella, who felt I had something useful to say and was willing to take a chance. So great for them, not so great for the people who passed, but okay.
Yeah. Why are people so afraid? Because again, to the average observer analyzing the situation, yes, you have the loudmouths on both sides. Yes, you have the politicians, but people as a whole seem to be trying to reach some kind of middle ground. And there's obviously a market for a book that says this is not a hoax, nor is this as bad as some of the people maybe on the left side of the aisle politically keep saying. But so here is a book that is clear, concise, to the point, and says, here's the information. Now do as you please with the information you have. Why has this book never been written before?
That's a really good question. All right. And many of my, look, there's a whole bandwagon effort movement behind trying to fight climate change. And I put those words in quotation marks. Really, it's about reducing emissions, which maybe has got something to do with the climate. And we've got many scientists who've staked their reputations, many institutions. You see increasingly industry getting behind this, the financial system. And we can speculate or maybe even talk about the motivations of each of those players. But I think somebody who writes the kind of book I did certainly takes a risk. And well, it's not a risk. I think it's actually a certainty that you're going to get denigrated. I've been called all kinds of names already. Fine. I'm far enough along in my career and I have enough stature. I really don't care. But I think it's important to lay out a transparent discussion of what we know and what we don't know. Why hasn't it been written before? I don't know. Many of my friends, some of whom are, much more on the green side, let me put it that way. They say, this is a good book and people need to be reading it. Of course, you've got two gangs of folks who've already trashed me in two publications, which we can talk about. It's kind of interesting what they did. But, I feel pretty good about having written it because I've got confidence in what I wrote.
Another thing you talk about, and you hear a lot in the mainstream media, is this idea of scientific consensus, right? There is a consensus, or whatever the statistic, 99 out of 100 scientists believe that climate change is an existential whatever. And well, it's hard to argue with 99%, right? To an outside observer, again, you go, well, there must be a problem. 99% say it, right? Where does this consensus come from?
So there was
this consensus. Sorry.
So what is the consensus? Yeah. So there was, the origin of it, at least quantitatively, with the 99, 97, was a paper that was published some years ago in which they did a survey of the literature and looked at, 10,000 papers and reported back 97% of climate scientists agree. The problem is two things. One is the survey methodology was terribly flawed. It's been roundly debunked in peer-reviewed papers published subsequently. Basically, most of the papers didn't take a stance one way or the other. Some, I don't remember how many, 10% said something, and even then, those 10% were not clear. So it's a pretty small sample. But more fundamentally, when people say the 97% number, they don't say what people agree or disagree about. Okay, is the climate changing? I'm on that. I absolutely agree with that. Are humans exerting an influence on that through growing greenhouse gas concentrations? Yeah, absolutely. Is it going to be a disaster? I don't think so, because that's what the assessment reports say. It's not going to be a disaster. All right. So in that sense, I'm a consensus scientist because I believe almost everything that's in the consensus reports, and that's what's in the book. So not a denier at all. Just maybe somebody who reads the reports actually, as opposed to just mouthing some slogans.
What do you attribute the exaggerations to? So the people that say, this is existential threat, we have 20 years to do something, we have 30 years to cut whatever emissions to zero. Again, I'm going to be honest, I'm not a scientist by in my day-to-day life. So I'm just curious. I'm coming from a curious point of view where I'm saying, well, why these exaggerations?
So let's start with the media, which maybe you have a better feel for since you're doing a podcast. The media have dedicated climate reporters who are usually not trained scientists at all. And unless they write dramatic stories, they're not going to get on the front page or prominent on the opening web page. And so you see reports all the time of dramatic weather events, which in the end have very little, if anything, to do with climate. Remember, climate is a 30-year average of weather. Not only the averages, but the extremes get averaged as well. So what happens this year or next year or 5 years ago, unless there's a clear trend over a decade at least, it's not climate, it's weather. But if we now go to the government, I quote in the book a line, and I won't get it right exactly, but from H.L. Mencken, who was a journalist in the early 20th century, who said, the purpose of practical politics is to keep the populace alarmed by a series of threats, most of them imaginary, so that they're clamoring to be led to safety. And whether it's immigration, whether it's COVID, whether it's cybersecurity or climate, these are all things that politicians can use in order to garner support for action. Some of them are legitimate. I in no sense doubt that COVID wasn't a very serious threat, and we can argue about how they dealt with it and so on. But crises are good for governments, and whether it's real or imaginary, it hardly matters to the politicians. Then you get to then you get to the NGOs, right? 350.org, Union of Concerned Scientists. If you've built a major part of your organization around the threat of climate change, and suddenly when you read the reports, you realize, oh, this is not such a big deal. What do? You hype the threat.
Is there a concern in your mind that if you do not hype up the threat, people can become reckless and do things that they wouldn't do if they knew that this was an existential threat? I'm not arguing I don't believe in this. I'm a believer in giving people the information and letting them do what they think is best. But do you believe that that's part of the reason why people exaggerate the?
Yeah, I think they really want to stimulate action, and they're really afraid for the future of the planet. Some of them, others of them see opportunity, whether it's financial or reputational or whatever. I think that we're more in danger on the other side, and there is. Many people talk about the existential threat of climate change. The Secretary of Defense has made it a national security issue. That's really, that says a lot in terms of the importance that they attach to this. And what I worry about, that the real existential threat is precipitate action to try to reform the US and global energy system. because on the other side of taking action is the fact that there are 3 billion people in the world who do not have adequate energy. And the most reliable and convenient way of getting them that energy is from fossil fuels. And so if you say we're going to decarbonize the whole world, because in fact you have to do the whole world because the US alone is not going to make much difference. When you say, well, you have to answer the question, what are you going to do about those 3 billion people whose energy use is growing because their economic lot is improving? And are you going to deny them reliable, affordable energy? And most people don't think about that in the West, the activists. They don't at all.
During the Obama administration, the United States joined the Paris Climate Agreement. What is your position on its is it important to have a agreement of that kind? And again, why is it so divisive? I understand politics these days are very divisive to begin with, but one side clearly hates it and the other thinks it's a great idea. So what's the disconnect?
Is it important? At the highest level, I say it doesn't make much difference because the governments make commitments and by and large, they don't meet them. And you can just look at the history of how well governments have met their emission reduction commitments. The second is it doesn't constrain the developing world at all. And that's where emissions are growing fastest and are in fact the majority of emissions these days. So unless you get the whole world to come along, this is not going to reduce emissions or stabilize the concentration. And I've not seen any indication, and in fact, I was just reading today, India, China, Indonesia are building coal mines like crazy because they need the energy, not because they want to pollute the planet. So you've got to square that away. In the US, why is it so divisive? Because first of all, if we were really to go emissions free as a country by 2050, which is what the administration claims is its goal, that's an enormous rearrangement of how we produce energy, how we consume it, and the way in which society is structured and behaves. The very simplest thing is that there are 10.5 million people who are employed by the domestic oil and gas company, and they account for 8% of the GDP. We're going to make that go away. We have about 1,800 fossil-fueled electricity generating plants in the country. If you want to make them all go away by 2035, you have to decommission 11 of them each month between now and the next 14 years. I don't think that's going to happen. I have friends who ran major utilities over the last decade at the very top, and they all look at this and they sort of snigger. How are we going to do that? That's just not going to happen. Now, you might argue that the goal of politicians is to set goals, or the role of politics to set goals and move us some way. But the fervor with which this is being promulgated really disturbs me.
When you worked for the Obama administration, did you deal with climate or did you deal with something else?
Well, climate was nominally under me, the climate research, but my main role within the government was helping the government think about its investments in energy technologies. So I wrote what's called the first quadrennial technology review, which surveyed what were possible energy technologies the government could be investing in, what is the status of each one of them, how material could it get to, basically how should the government formulate its energy investments. And I was well suited to that, having spent time thinking about that in BP and naturally having a kind of synthetic orientation. It was a lot of fun. The climate was going on, but it was a couple of layers below me. And frankly, it would have been very difficult for me to start messing with it anyway, just given the rest of what was going on in the government.
Mm-hmm. And what did you find in your research at the time?
Well, I mean, at the highest level, I would say the country can have any kind of energy system it wants, as long as it's willing to pay the financial and political capital to bring it about. The current favorite is to run the country on wind and solar. You can't do that unless you've got storage or backup of some kind. The most discussed backup is some kind of energy storage, whether it's hydropower or even gravity, lifting weights up and down, or big batteries, or making chemicals out of the energy and then burning them at night, during the day when you need them. I mean, none of these can be economical or work at scale with the current levels of technology. The one that could is nuclear reactors, fission. We've had a hard time building new nuclear reactors in this country for a variety of reasons. And to think that we could build enough reactors, whether they're big ones or small ones, in the next 14 years to back up the system is just, it's fantasy. It's fantasy.
Why is it fantasy?
Because you got to get the reactors licensed and then you got to build them.
Mm-hmm. How long does that take? I'm sorry, I just don't know.
Well, it takes so if you build a big reactor the way we have been doing them, it's many years, 4 or 5 years to get the thing licensed, and then another 3 or 4 years to build the thing, and then it starts working. So figure almost a decade. In the Department of Energy, when I was there, and more recently, has been funding research and development on small reactors, maybe 1/10 or even 1/20th the size of the big ones. And if we could build those in a factory, put them on rail cars and ship them to the site, so the licensing would be much easier. It's not a different design every time. Then maybe you could start cranking them out, but nobody's built the first one yet. So it's a long way off.
And what are the biggest concerns with nuclear? Obviously, we have the clear examples of Chernobyl and examples like that, but yeah, are those the main arguments?
I think it's safety and it's waste are the concerns most people have. I think those concerns are much misplaced. You should know you're talking to a nuclear physicist, so I have perhaps a natural bias, but I also have some knowledge. People worry about Chernobyl or 3 Mile Island, but of course the new designs certainly try to mitigate against that kind of incident. And as far as the waste goes, we have solutions that are technically and economically feasible. It's a question of the perception in politics, whether we can get around that or not. Most people have no idea about the scale and scope of the energy system and what it takes to make it work properly, whether it's electricity or fuels for vehicles or heat for buildings. And I wish everybody could understand that. And then they would realize that with all of the uncertainties in the climate problem, navigating and changing the energy system is going to be even more difficult.
You just mentioned the fact that there is a way to get rid of nuclear waste, correct? Yeah. What are some of those ways?
So long-term monitored retrievable underground storage are the buzzwords, okay? First of all, you'd like to put it underground when the radioactivity is cooled down enough, about a decade, to keep it isolated and safe. You want to monitor it to make sure that it doesn't do anything you don't want it to do. But you also want to be able to perhaps retrieve it at some point centuries hence, because there's a lot of energy in the waste. We only extract about 5% of the energy in the waste. So we burn it up and then at 5%, and then let it cool down for about a decade and put it underground. And it's all perfectly doable, technically fine. Is it absolutely safe? No, nothing is absolutely safe. But the real and projected accident rates dealing with waste, pretty small.
And what happens when you put the waste underground?
It continues to cool. I mean, the waste has been formed from the metal and ceramic that was in the reactor. It's been formed into a glass, and it just the radioactivity decays on a very predictable time scale.
And where nuclear reactors usually built? Obviously, do they have to be outside of big cities or?
Yeah, you don't want to build them in cities. You want cooling for them, so you build them on rivers or on the coast because they generate a lot of heat, and you need to cool it. Only about 1/3 of the energy that they produce gets turned into electricity. Most of it is heat, and so you need a big flow of water to keep it cool, whether it's on a river or on the coast.
Does that have any negative adverse effects?
Well, you know,
on
some
the
people
rivers?
people worry about the heat in the rivers and so on, but it's pretty well spread out. And I think, you know, in certain places, the fish actually like it, the marine life. It's a little warmer, of course, than the surrounding water. No, that has not been a concern.
This is quite fascinating because there is a listening to you, and then there are other people that will say that nuclear might not be the best way to go because we don't know how to get rid of waste. I've heard that for a long time, but you just outlined the way to get rid of waste. Why is this not more?
It's there. It's out there. You should also understand the volume of the waste is not enormous, right? I can't quite give you a good physical dimension, but it's not mountains and mountains of this stuff. It's pretty small.
What's
could fill an aircraft hangar, something like that, for the whole country. Yeah.
And the waste is buried next to the reactor?
No. So we do go a little bit through the fuel cycle.
Yeah.
When you pull the fuel out of the reactor,
Okay.
and you pull some fraction of it out every couple of years, it's pretty radioactive. And so what you do is put it in a swimming pool, as it's called, a cooling pool, for I don't know how many years, 5, 10 years. I don't know the exact number. We could look it up. And then you further put it, after it's cooled enough, and that time you put it into a giant, very highly engineered barrel, basically, that sits on the reactor site. And you let that cool for some additional number of years. And then you can take that waste and process it and turn it into glass and stick it underground. So it takes a couple decades to do that, but it can be done.
Wow. If the whole country was powered by nuclear, for example, how much waste, how many airplane hangars would that?
Yeah,
that
you know,
make?
I don't know that number off the top of my head. I'm not going to quote it for you, but it's not very big.
Mhm.
It's not. We can look it up. I'm not going to look it up right now. It's enough so that you could dig a mine and put the stuff down in the mine, salt cavern. Actually, you could do that. We had the shame of all of this is that the country, had studied and engineered a site in Nevada called Yucca Mountain, which is somewhere deep under a mountain. All the geological studies had been done, and we were all ready to go. And then Harry Reid, who was the Senate Majority Leader at the time, from Nevada, where the site would have been, basically said, no way. And so that has been put on pause, if you like, or indefinite hold, waiting. But, you know, I would say you've got to have nuclear if you want to go emissions free. And people will just eventually come around to that. So, for example, Stuart Brand, who is a prominent environmentalist, he wrote the Whole Earth Catalog back in the 60s and 70s. He's a big supporter of nuclear power now. Bill Gates, who wrote the book, big supporter of nuclear power to the extent that he's investing in developing nuclear technologies. So I think people who look at this with the engineer's eye will realize you're going to have to do fission if you want to go to zero emissions.
Maybe to segue a little bit into the crux of the book, there's a lot of general talk, as we discussed throughout this podcast, about what are the facts behind climate change. And would you mind outlining what are the facts?
Yeah. And so I will give you again, these are subjects with nuance and subtlety, so
Mhm.
I'll do my best to give you some
People,
sound
people,
bites.
people can buy this book.
Yeah, but
Yeah.
and I've tried my best to tell the full story about many of these points in the book. Humans are influencing the climate through growing greenhouse gas concentrations, but also through aerosols that we put up by burning dirty coal or doing other things that produce particles in the atmosphere. The greenhouse gases exert a warming influence, and the aerosols exert a cooling influence, not enough to balance it out by any means, but enough that you got to worry about it when you start to get quantitative. We have seen the average temperature of the planet, which is a difficult thing to measure, as you would imagine, go up by about 2 degrees Fahrenheit, 1 degree centigrade, since 1900. But interestingly, that rise has not been steady, even as the greenhouse gases have been accumulating in the atmosphere. We saw a pretty rapid rise from 1910 to 1940, and then it went down. The planet actually cooled some from 1940 to 1970 or 75, and then started warming again. And the rate of warming in recent decades is about the same as the rate of warming from 1910 to 1930. And that's really 1940. That's really interesting because it says there's got to be something else affecting the temperature beyond just accumulating greenhouse gases. In fact, human influences on the planet as a whole were less than 1/5 of what they are today before 1950. So the lesson is the climate varies a lot on its own, and untangling the variation due to human influences versus what's natural is a major challenge in climate science. We do that by trying to understand what the climates were in the past. We had thermometers back to about 1880 over a lot of the planet. Beyond, further back than that, we have various fossil records, historical records. And then we have today, of course, satellites and floats going through the ocean. So very important, because the ocean is really where climate happens, because it stores all the heat. The atmosphere changes every few days, but the ocean takes decades to change. So we got to understand the ocean. And when you do that, what you learn is that at least in the last 100 years, apart from the warming of the planet, most extreme events show no detectable trend. Droughts, floods, hurricanes, and no detection of human influences on hurricanes over almost 100 years. Most people are kind of surprised by that. You can look at other extremes, small scale storms, thunder, storms, hail, no effect. Sea level in the last few decades has been rising a little more rapidly than average. Do you know, so I can ask you a question, I'll give you a quiz. Do you know how fast sea level is going up at the Battery in Manhattan, the tip of Manhattan? Okay. About 1 foot every century. That's not a lot, is it? It's like an inch in a decade.
Right.
Okay? The last couple decades have been a little higher than that. But if you go back 40 or 50 years, it was a lot lower than that. And go back again, it was a lot higher than that. It's in the book, you can see the graphs. This is not Steve's data, of course, this is official data from NOAA. And so there's a lot of natural variability in the system. And it happens on long time scales, many decades, and untangling that from human influences is a pretty difficult job.
And sorry, I don't mean to interject.
Please, no.
What causes that variability? I assume there are multiple factors.
You know, some of it is, a little bit of it is natural forcings, as it's called, changes in the sun, volcanoes go off and they cool the planet a little bit. But a lot of it is poorly understood internal oscillations of the climate system, internal cycles in the climate system. They're quite definite. It took a while to discover them. There's one in the Atlantic called the Atlantic Multi-Decadal Oscillation. There's one in the Pacific called the Pacific Decadal Oscillation. These take about 60 or 70 years each. Most people are familiar with El Nino, which happens every 5 or 7 years, takes about a year or two, much shorter time scale. The models do not a bad job of describing that, but they're pretty clueless about these longer term cycles. And unless you get them right, you don't know whether what you're seeing is a result of the cycles or it's a result of human influences.
I don't know if anybody in the Biden administration read your book. I sure hope so. But if Joe Biden calls you right now and says, Steve, what do I do? And how much do I spend perhaps on fixing some of the, you're not denying that there are some environmental issues. What do I do and how much do I spend?
Yeah. Well, the first thing I would tell the president is read the book and then let's talk. I have in fact sent the book with no response to the president's science advisor and to his two deputies, if you like, the people who chair what's called PCAST, the Council of Advisors on Science Technology. I know all of them personally. I've not had a response from any of them yet. And of course, I sent the book to presidents of the national academies. Again, I know them all. I hope they read the book and I hope they're willing to discuss. But what would I tell the president? Have you read the book? Mr. President, please do not use the science as a club in the political discussions. The science is what it is. It's uncertain. But where you have a role is in helping to form a values consensus. Help the public understand, given the uncertainties and the downsides of taking drastic action, whether the values, intergenerational equity, north-south equity, environment are such that you want to make this kind of drastic push or not. That's not about the science, Mr. President. That's about what the priorities and values are of the nation. And it's your job to frame the conversation like that and lead that discussion. But please do not over-exaggerate the science, or when people point out what's really in the science, do not dismiss them as flat earthers or deniers. That isn't a great answer, right? I mean, it's not crystal clear, but these are not crystal clear issues.
Right. You just brought up the topic of being called a denier or flat earthers. I see that one as very offensive to anybody trying to discuss the issue, to automatically look, we have flat earthers. Those people exist. I don't know how many, but I'm sure they exist. Climate deniers, we also have a fair share of those too. But to deny the fact that there is more nuance, that just that this is not a black or white conversation, that it's more nuanced than that, is intellectually dishonest and is against open inquiry. You say in the book that you find the fact that being called a climate denier equated to a Holocaust denier is personally offensive to you. If I were called the same thing, it'd be personally offensive to me because, you know, we had relatives lost in the Holocaust, and it's it's just offensive. What do you see maybe this is it's not really a science question, but a general question. What do you see? Are you optimistic about the future of open inquiry in America?
Not at the moment, no. I mean, again, just to put a little color on it, Scientific American published a week ago a piece by a dozen climate scientists, and it was led by a professor at Harvard, Naomi Oreskes. I want to name names because people should know who's doing this. Second author was Michael Mann, a prominent climate scientist at Penn State. Another was I'm blanking now, but the principal author of the last national, Don Roberts class. And, these are credentialed scientists, but to write a piece that is 95% name calling without foundation is just so outside of the behavior of ordinary scientists that I think they have beclowned themselves, if I could use that word. So I'm not optimistic when it's that deeply ingrained in both the scientists and the publication that would publish such a thing, and of course not let me respond. I submitted a response, they turned it down. I'm not optimistic. On the other hand, I've gotten so much positive feedback unsolicited from people who say, gosh, I read that book, it opened my eyes up. Everybody should read this book. Including some people actually who I would have thought would not have said that. But, I'm just a guy trying to lay out the facts. I'm not denying anything in the reports. I'm just repeating what's in there. So maybe we can get to a more factual basis. There's another thing that perhaps bodes well. And it's a funny thing, funny way of thinking about it. As the administration starts to take actions that affect people directly, for example, you would not be able to buy an internal combustion engine car after 2035, or your electricity reliability and costs are going to go up, reliability down, as we start to tinker with the grid. Our national energy security will be degraded if we cut back on oil and gas production domestically. But those start to affect people's lives, perhaps their jobs. And there's going to be a much greater call for a scrutiny of the scientific motivations for this. And people are going to start to ask, tell me again why we're doing this when you have that kind of disruption. And in the same vein, if this is really a national security issue, it deserves the same scrutiny that other national security issues do, like how far along is North Korea in their atomic weapons program, or what's the capability of the latest Chinese submarine, or whatever. And that's a much more rigorous scrub than anything that climate science has gotten to date. And I hope that we will get to that point, and that we can then have a more fact-based discussion of these matters.
Yeah, I'm with you on that. I want to start wrapping up, and the last two questions I ask of all my guests, to maybe end on a more positive note than too much negativity in the world, unfortunately. But the first question, I'll put them together, and you can answer in whatever order you prefer, and however you prefer. The first one is, what gives you hope for the future? It could be as general or as narrow as you please. And the next one is, what are 5 books on any topic, fiction, nonfiction, that you would recommend to people?
Oh gosh.
That's how I get
hope,
people.
Yeah, right. Hope for the future. Okay. I think I have great hope for the future. There's a statement, famous line from C.P. Snow, who was writing in the 50s and 60s about the culture of silence and its relation to the humanities. And he said, scientists have the future in their bones. And I do have that. I have great faith in our ability to invent, to discover. I think the ability to produce several COVID vaccines within a year, to the point where we're comfortable giving them to very large numbers of people. That's a tribute to the scientific progress that we've made over the last 40, 50 years in understanding biology and biochemistry. And there are many other things going on in information technologies, artificial intelligence, materials that are just wondrous. So that's one thing that gives me faith. The second is that humans have been demonstrated to be very adaptable. And I think it's going to be unlikely that we will reduce human influences enough to make a difference over the next 60, 70 years. At the same time, I don't think the climate's going to change all that much, that dramatically. That's an opinion. But I do think that humans are so adaptable that whatever changes are brought to us, we will manage. And we've done that historically very well. We managed to adapt societies, from Hudson Bay all the way down to the equator, and do that pretty well. So we'll get by. I think it has been unfortunately irresponsible by many of the climate establishment to have scared the bejesus out of people of your generation and a bit younger. That's just immoral, I would say. Books, what's on the top of my head right now is energy books. There's a guy named Vaclav Smil, S-M-I-L, who I discovered about 15 years ago, maybe a bit more. Just a wonderful way of thinking about energy. And so I would recommend any of his books. On the historical side of energy, Dan Jurgen, whom I know has written a number of great books about the oil business, the oil process, how oil came to be, and more recently about renewables, and then about the geopolitics of energy. So I like Dan's book a lot as well. Jared Diamond, Guns, Germs, and Steel was something that opened my eyes that you could really have a theory of history or try to explain the trends and how that worked. So that's a few books that I think are pretty interesting.
Wonderful. Stephen
Koonin.
Oh,
one more.
Go.
Bjorn Lomborg's books. Bjorn is an economist, and he and I, within the last year, have been talking quite a bit. I think the way he looks at the climate energy crisis, alleged, or climate energy problem, let me call it that, is very aligned with what I'm thinking. He comes at it from the economics point of view. I come at it from the science point of view. Not that economics isn't a science. And then, Schellenberger's recent book also comes at it more from the environmentalist point of view. So I think those three books are of a piece saying, wait a second, this is maybe not as big a problem, and the solutions that are being proposed are maybe not optimal.
Michael Schellenberger, Apocalypse Never, is that what it's called?
Yeah.
Awesome. I'm obviously going to link all of those books to my YouTube and Spotify, wherever. I want to thank you for taking the time to speak with me today, and for, once again, writing this book. It's very important, and I appreciate the open inquiry and analyzing facts and just giving them to the people. So you've done a great service.
Thank you very much. Great chatting with you.
Thank you.